All right, let's get right into it. For decades, we've been told a pretty simple story about cholesterol, right? You've got the villain, LDL, the bad cholesterol, and then you have the hero, HDL, the good cholesterol. But what if that story isn't the whole story? What if it's kind of wrong? Today, we're going to unravel the fascinating myth of HDL cholesterol.
And this is really the central question, the one that's turned decades of medical thinking on its head. It's a puzzle that really started when all these treatments designed to boost our so-called hero molecule started to fail. And sometimes they failed spectacularly. So let's explore this incredible turn in cardiovascular science.
Okay, so first, let's set the stage. We need to talk about the classic tale, the one we all know and love. This is how HDL got its heroic reputation in the first place.
So, what exactly is our hero, high-density lipoprotein, or HDL? Well, you can think of it as a particle in our blood that acts like a tiny microscopic garbage truck for fats like cholesterol. Its main job, as we always understood it, was to be the good guy, the one that swoops in and cleans up our arteries.
And this is exactly why everyone thought it was so great. Big, important studies like the Framingham study found this really powerful connection. For every single point you increased your HDL cholesterol, your risk of dying from heart disease seemed to drop by a whopping 2 to 3%. I mean, with numbers like that, the mission for the medical world was crystal clear. Just raise HDL.
And this is a big but. This is where our story takes a really dramatic and totally unexpected turn. That simple mission to just raise HDL levels, yeah, it ran headfirst into a very, very big problem.
Just take a look at this timeline. It represents a solid decade of pure disappointment. One massive drug trial after another, all of them designed to do just one thing: raise HDL. And they all ended in failure. Some of them showed zero benefit at all, and one trial, Illuminate, was so disastrous it actually increased mortality. The evidence was just becoming impossible to ignore.
This left scientists with this huge, glaring contradiction. I mean, if high HDL is so good for you, and these drugs successfully raised it, why on earth didn't they help patients? This one question forced a complete top-to-bottom rethinking of everything we thought we knew about good cholesterol.
And that brings us to the deeper truth, the real answer. It turns out the secret wasn't in the quantity of HDL, but in its quality. It's not about how much HDL you have, it's about how well it actually works.
So think of it like this. The old focus was just that one number on your lab report, your HDL-C level. Plain and simple. But the new focus is all about HDL function. What is that little particle actually doing inside your body? Is it an efficient, hardworking cleanup crew? Or is it kind of just asleep on the job? HDL's main job is something called reverse cholesterol transport, or RCT. Think of HDL as your body's dedicated cleanup crew. Its particles travel to your tissues, like the walls of your arteries, pick up excess cholesterol and carry it all the way back to the liver to be disposed of. This process is absolutely critical for preventing plaque buildup.
And that is not all. A truly functional HDL particle is a multitasking marvel. It's also anti-inflammatory, it acts as an antioxidant to protect other particles from damage, it helps prevent blood clots, and it supports the health of the very delicate lining of your blood vessels. So a truly good HDL particle is incredibly busy.
But what happens when our hero gets corrupted? This is where we see that, under certain conditions, HDL can actually go from being a hero to, well, something much more sinister.
And this is the critical twist in the story. In the presence of systemic inflammation from other diseases, the HDL particle itself can be damaged. It just stops doing all those wonderful jobs we just talked about. And even worse, it can flip sides and become pro-inflammatory and actually harmful.
And you can see here how different diseases can actually corrupt HDL. For instance, during a heart attack, inflammatory proteins can literally hijack the HDL particle, stripping away its protective parts. The result is pretty much the same across all these different conditions. The hero has been turned.
So with this new knowledge about functional versus dysfunctional HDL, that old simple rule of more is always better had to be thrown right out the window. It's been replaced by a much more nuanced and, frankly, a much more interesting model.
The old view was a straight line. As your HDL goes up, your risk goes down. Simple. The new view is what scientists are calling a U-shaped curve. This means there's sort of a Goldilocks zone. Too little is definitely bad, but as we're now discovering, too much can be bad too.
And this visual really makes that U-shaped risk clear. This is based on recent large-scale population studies, and it shows that all-cause mortality is highest at very low levels of HDL, just like we always thought. But look at the other side. Once you get to very high levels, we're talking above 90 milligrams per deciliter, the risk starts to climb right back up again. That sweet spot, the very bottom of the U, is where the lowest risk lies.
So, let's pull all of this together. What does this new, more complex story of HDL actually mean for our understanding of health and disease? What's the takeaway?
Well, the big bottom line is this. A high HDL number on your lab report is not a get-out-of-jail-free card. It doesn't automatically guarantee protection, and in fact, extremely high levels might even be a red flag for dysfunctional HDL. This means the future of cardiovascular medicine is shifting. We're moving away from blindly trying to raise levels and moving towards improving function. The quality of your cleanup crew matters way more than its size.
And maybe the best way to end this is with this thought. As the researchers behind our source material conclude, quote, "The HDL code is yet to be fully deciphered. We've learned that the old, simple story was too simple, but the new, more complete story is still being written. And that's a powerful reminder that science is always evolving, and even something as familiar as good cholesterol can still hold some profound mysteries."